Hi, everybody. Welcome to this amazing webinar. We have a great speaker today, Olivier Toubia. I will introduce him and then, well, first, how are you, Olivier?
Good, and you? How are you doing? Nice to see you.
Nice to see you. Thank you so much for taking the time to talk about your one of your most recent papers. Um, who's Olivier? Olivier Toubia is a Glovinger Professor of Business at Columbia Business School, where his research focuses on marketing science, innovation, behavioral economics, and Gen AI. He earned his PhD in marketing from MIT Sloan and SM in operations research from MIT as well, and in engineering degree from the École Centrale Paris. I don't know if my French is
Pretty good, pretty good.
well. Well, and his recent work on digital twins explores whether AI can simulate real people well enough to improve customer research, market testing, and business decision making. Really interesting paper, by the way, Oliver.
Thank you.
So
Uh,
before starting with the conversation, well, first to all the audience, we are live, so please write down all the questions where you are watching it, mainly LinkedIn or YouTube, and we will like Oliver will answer on the way, and I will share with you a link where there's like a lot of really relevant information uh, about the lab, the CBS Digital Twins Lab. Can you tell us a little bit of
yes, yeah,
it?
sure, yeah. Yeah, I mean, so at Columbia Business School, a few of us have been pretty actively doing research around synthetic data and digital twins. And we recently created a lab that, has a lot of resources. And I will talk about this in my remarks, but the goal really is to encourage rigorous, replicable, transparent investigation into synthetic data. And so we have publicly available data sets, code. I'll show you some platforms that we're developing to allow people to quickly experiment and learn. It's a very exciting area, lots of interest, lots of hype, but also lots of uncertainty. And we want to be able to help learning in that space and being able to help people test and experiment.
Great.
Uh, so should I start or?
Yes. So, Oliver, feel free to start. I will be out of the stage, but still in the back. And thank you so much. See
Yeah, thank
you
you.
at the end for the Q&A. But please, everybody, ask questions. He will be answering on the way.
And then also, yeah, so I'm happy to make this interactive. If there's questions and I don't see them, Alejandro, don't feel free to interrupt and let me know if there's a question that I could address. We don't have a lot of time. We'll try to make this interactive. I have a lot of stuff, but I won't go into everything. I just want to give you a bit of a taste of what we're doing and answer questions as they might arise. So this talk is going to be based on primarily on two studies that I've been conducting with my colleagues at Columbia Business School. So I will and the link that Alejandro put on in the chat has all of these resources there if you want to find out more. This is a group of colleagues with whom I've been working, a very wide range of experts from different areas: finance, economics, management, operations, machine learning, marketing. It's been a lot of fun working with all these wonderful colleagues, people from computer science as well. So as I mentioned, we created this Digital Twins Lab, which is really about transparency, independence, rigor, accessibility. We're very excited about digital twins and synthetic data. And we want to be able to learn as quickly as possible as a community, whether it works, how it works, when it works, how it can be improved. So we think that this requires in kind of an open source mindset where really people can share resources and learn together fast. The and I'm sure some of you know this. There's been a lot of excitement in academia and industry about synthetic data, being able to basically use LLMs to simulate how humans would respond to any types of questions, stimuli, response to advertising campaign, new products, um, articles, ad copies, um, ask questions like you would ask in the focus group, get customer insights. So being able to basically ask all of these to LLMs instead of humans, and if this works, this would be amazing because it's definitely faster. You can just, very quickly get a response, cheaper because you only have to pay for the cost of the API, which is not as much as paying people for their time. And maybe even possibly better because LLMs never get tired. They give you detailed answers. They don't lie, typically, at least. And that you can ask them anything, even sensitive questions. So this really opens up a lot of exciting use cases. And so there's been a lot of excitement, also some skepticism. The initial efforts in that space came from what I would call synthetic personas, which is basically taking the LLM. Suppose you are a 35-year-old, Hispanic female who lives in Chicago, and that's your occupation. Like, how would you respond to this question? And so we saw quickly that this approach has some limitations. It doesn't really capture fully the heterogeneity of in the population and the nuance of how people think. So one particularly promising idea in that space was to do what we call digital twins, which is why don't we actually take a real person and get enough data about them from them through different methods to be able to really create an LLM, an agent who's going to be trained to mimic their specific behavior. So if that works, then maybe we'll be able to really reduce any bias that you see in LLMs because we really align on one specific person. We may be able to really have panels of LLM agents that represents diversity in the population. And there's a very exciting use cases, basically agentic AI. These agents could then do many things beyond market research. So that's kind of the promise of digital twins. Lots of industry interest. The market research industry is definitely the first one to be concerned by synthetic data, but there's many other industries beyond that also that could be disrupted. This is one example of a startup that was created by the co-authors of the first paper on digital twins, raised $100 million recently. There's already a few startups in that space with roughly in the order of $1 billion valuation in the synthetic data space. So lots of VC money being poured into that, lots of companies interested, consulting firms. But at the same time, we don't really know how well it works. There's a lack, again, of replicable, publicly available information to really allow us to test whether digital twins are able to predict behavior in completely new domains and how they compare to relevant benchmarks, like simpler agents that are maybe only looking at demographic information rather than extensive data about a person. And then does it work better in some domains, others? How should it be done? And all of this really requires, we think, publicly available resources to be able to test. So we're not selling anything. We are researchers. We're just interested in finding out knowledge and helping our colleagues in academia and in industry learn faster and be able to kind of explore this very promising technology. So the first thing we did was put together a publicly available data set that could be served as a blueprint for creating digital twins. So we went ahead last year and we assembled a panel of over 2,000 US consumers who are representative of the population. And we asked them over 500 questions over a few weeks. So we had 4 different ways. And then we asked them, of course, the demographics, but then we add basically most of the major psychological scales that exist, the personality measures, Big Five and others, a bunch of IQ style questions, measuring their economic preferences, risk aversion, loss aversion, And then we ran 16 experiments on these people that come from the heuristics and biases literature. So these are classic experiments in behavioral economics, testing people's behavior. And then we also asked them a survey in which they indicated whether they would purchase 40 different products at different price points. The last two sets, the experiments and the product preference survey, we actually asked twice. This way, we have a measure of how consistent the humans are themselves. So we know that if you ask the same question to a human, let's say 88% of the time or 82% of the time, they would give you the same answer. So that really gives us an upper bound as to how well a digital twin could predict, because if myself, I'm not consistent with myself, then how could an agent predict my behavior if my behavior is a moving target? So we have that measure of test-retest accuracy as a baseline against which to compare the digital twins. All of the data are publicly available on Hugging Face, and so the link is on that lab's website that I shared. That was shared in the chat. So the data are there. It's being downloaded by academics, practitioners. And it's been very exciting to see people use the data in many different ways. So that was the first thing we did. And I won't go into all the details, but we did some early tests with this data about basically using someone's demographics, psychological profile, cognitive tests, economic preferences to create a twin for that person. So it's basically giving an LLM a transcript of all of these 500 questions and answers, and then asking the LLM to behave in a way that is consistent with that person. So basically asking the LLM to take on a persona that is described by this history of questions and answers, and trying to see how well this can predict then their behavior in different experiments. And we found that the humans themselves, had some test-retest accuracy, and the digital twins were able to be about 88% as accurate as the test-retest accuracy. So it looked pretty encouraging that actually digital twins were able to not be exactly as accurate as the humans themselves would be when you ask them the same question twice, but pretty high up there. But this was just an early test in a pretty narrow set of experiments. And also we try to see whether the effects in the experiment would replicate with the twins, and there actually we found that only about half of the effects would replicate. So if you do an A/B test with a human sample and you find that the condition A is higher than condition B, for example, in only about half of the cases would you find the same with digital twins. So this was a bit of half empty, half full type of finding. It was an initial set of findings. And just like a couple of fun observations, looking at the actual answers from the twins and the humans, we found, for example, that digital twins had a very hard time unknowing information. So there was a question, for example, in which we asked participants how many African countries are in the UN. The correct answer is 54. Only 10% of the humans knew the answer, but actually 99% of their twins gave the correct answer, because this information is part of the corpus on which the base LLM is trained. And so it's hard for a twin to behave as if it didn't have access to that information. So we see this hyper-rational behavior, hyper-knowledge behavior. We also found that twins tended to be pretty favorable to the medical profession, so like pro-vaccination. So we thought maybe there's some early indication of some political, maybe kind of skew. We also found that twins had a hard time expressing conservative opinions. So when asking humans whether they would support deportation of illegal immigrants, about 45% of the humans said yes, but only 25% of the twins said yes. So even though the twins knew the political beliefs of the person, it was hard for the twins to actually express conservative opinions. So again, maybe some early evidence of some political skew. And so these were all just some early indications. So then we decided that we needed more information to really test these digital twins. So that's where actually we gathered a group of 23 colleagues who together actually designed 19 studies. So we have people from different areas interested in luxury consumption, privacy preferences, algorithmic hiring, political advertising, a very wide range of domains that design studies. We pre-register these studies, which means that we announce beforehand, here's what we're going to ask, here's how we're going to analyze the data. So there's no cherry picking. We kind of pre-registered all of the data and the main analysis. And then we went back to the same 2,000 people that we had surveyed for the Twin2K 500 data set. We ran these 19 studies on the humans, and then we ran the studies on their digital twin. So each time a human answered a question, we asked the exact same question to their digital twin. So to an AI agent that is basically trained to mimic their behavior. And so now what we have is we have across 164 different measures, across 19 studies, across a wide range of domains, we have the behavior of humans and the behavior of their twins. So we can make an apple-to-apple comparison, matching each person's response to their twin's response to the same question across a very wide range of domains. So this really gives us a nice ability to test across, again, how well the twins mirror human behavior across a wide range of domains. And so let me pause here, see if there's any questions already. Alejandro, any questions?
Not so far, but the
Okay.
really interesting. Thank you so much.
Okay, sure.
Yeah.
Okay, so we're going to look at the accuracy of the twin. So how, if I answer 6 on the 7-point scale, is my twin going to answer 6 or 5 or 3? So how far are the twin answers to each person's answer? We can also look at the correlation, which means that if I'm high on this scale, is my twin going to be high as well relative to other people? So that's more like looking at the variance across people. We can also see whether at the population level, we're able to replicate the average response and the variation in the responses. And so basically what we found was a bit disappointing, to be honest, and underwhelming, but I think also interesting. So we found that the accuracy was pretty high. So the full persona is when you give to the digital twin the entire set of questions that the person answered, and then you ask the twin to predict the answer. So the accuracy was about 75%. But we found that actually you get basically the same accuracy if you only give the demographics data to the twin. So we didn't find really that having these 500 questions that we ask that cover a wide range of scales and domains really helps us really better predict how this person would respond. And then we found also that at the population level, the average response was not really improved either when giving this extra information. Now, in terms of the correlation, which is if I kind of relatively high on this, is my twin also going to be relatively high on the same measure? Here we found that actually there is improvement. So if we feed the full 500 questions to the twin, the correlation is higher than if we only give the demographics. But the correlation is only about 0.2, which is actually pretty low. To give you some ideas, this is about the same as the correlation between height and IQ. So it's pretty modest correlation. So we find that the twins are able to capture some variation across people, but not really, the full richness of how human behavior changes. And we also found that the standard deviation, so the amount of variation in the twins' response, was less than the human. So there's the twins' responses were not as diverse as the human responses. I'm going to maybe skip this. I'm going to skip this for now as well. So looking a little bit more at the exact data and the responses, and going beyond the number, because 80% or 75% doesn't really mean anything. You have to know when in the other 25%, what's happening, how are they deviating from human behavior. We found 5 systematic ways in which the twins distort human behavior. So that's why we came up with this analogy of a funhouse mirror that is kind of distorting a little bit the human behavior. So first of all, we find insufficient individuation. So we find that the twins don't really customize the behavior to each individual. They tend to regress a little bit towards the average. So there's not enough really ability to capture the unique thoughts and behavior of a given person. The what we observe is a bit more kind of homogeneous. We also find stereotyping, which means that to the extent that we see variation across twins, they tend to be based on stereotypes coming from demographics. So the customization seems to be heavily based on the demographics and not as much based on the psychographics of the person. We find also representation bias, which means that the humans who tend to have higher education and higher income, their twins tend to be more accurate. So if you use this technology, it seems like the voice of the elites is going to be better captured in your data, in your synthetic data, than the voice of maybe some more marginalized communities. We also found that people who have more extreme political views or more extreme religious attitudes, also their twins are less accurate. So it tends to better capture people who are high in terms of education and income and moderate in terms of political beliefs. We also find some ideological biases. We found that the twins express opinions that were systematically pro-technology. So they tend to portray technology as a good thing, as a friend, and being in favor of technology. At the same time, they seem to be pro-human. So they tend to express opinions like we can trust people, we should help each other. So it was interesting at the same time being pro-tech and pro-human. But then when they had to choose, so there was one study in which we asked them to evaluate ideas, and then when we told them the ideas, came from humans versus AI, they actually rated the ideas from the humans lower because they came from humans. So they tend to actually have a bit of human aversion when it comes to comparing AI to humans. And then again, we find hyper rationality. So the twins tend to again behave like super rational beings that don't have limited cognitive abilities, and so they're able to be super rational and super knowledgeable and basically very smart and smarter than their humans counterparts. So these are systematic ways in which we're seeing some deviations between the twins and the humans. So we think that these are issues that have to be addressed before we can safely deploy digital twins without testing each use case. So that's kind of in a nutshell what we have. And as I mentioned, we really want to make it easy for everyone to explore. We want anyone who's interested in this to be able, with little effort and resources, to be able to just try. I want to run a survey on digital twins. I want to ask a few questions. So we created this non-for-profit platform. It's called Explorer Twin, which is based on our 2000 twins, in which you can go and ask any questions. If you have a survey that you created on Qualtrics, you can also upload your survey directly and then run the survey on the twins and then get a CSV file with the answers from the survey. So we're currently in the beta testing mode. So we're looking for feedback. We're looking for beta users. So currently it's free. So if you're interested, join the waitlist and email me, and we can give you some beta access. At some point, we're going to have to start charging a little bit for this because the API usage is costly. But we know it's probably in the order of a few dollars to run a study. So it should be very easily accessible, very low friction and low cost. So again, to make learning faster in that space. So there's a QR code here, and also the link is also on the Digital Twins website as well. And so just some future research and ongoing things. I think it's interesting we need to really figure out exactly how we should think about these digital twins. Should we think of them as clones of the humans, or more like hyper-rational, agents that happen to know a lot about you? So maybe we should think of them as well-informed advisors as opposed to a carbon copy of the human. So we need to, I think, figure out exactly how to think about them in the right way to decide what are the use cases that make the most sense. But we are currently exploring interesting use cases of digital twins. One of them is being able to talk with your own twin. So that's something that a lot of people are interested in. The ability to do introspection, to kind of learn about yourself by talking to this version of yourself. So that's something we're exploring. We're also exploring having people talk to twins of people who are different from them. So maybe if you're a Democrat, or Republican, and you don't really want to talk to a human from the other side because there's like polarization. We find people are more willing to talk to an AI agent who's capturing someone from the other group. And we find that by having this conversation, actually, this can reduce polarization and also improve empathy and perspective taking and reduce stereotypes. And then there's a lot of agentic AI applications of digital twins. You can create an agent that's basically going to be able to represent you on decisions, go shopping on your behalf, maybe date on your behalf, and if they're able to actually capture your preferences. I have a colleague actually who's currently, I'm not working on this, but she's actually developing faces for these twins. So this is a synthetic face of a synthetic twin. So this is not how the real person looks, but this is how she may look like given her profile. So now you can give a face to these twins. You can use other technology to create avatars and be able to have conversations with them. So there's endless agentic AI opportunities to be able to have these agents represent you and then hopefully capture your preferences. And then there's also some interesting research being done on what we call self-improving AI systems. So maybe you have AI agents who are going to come up with ideas for new products. And then you have digital twins that are going to give feedback on these products. And then the AI agents are going to revise the products. And then you have this feedback loop, which would normally take a lot of time. Now it can be done very quickly because it's all done with AI agents that are very quickly able to iterate and find a new innovative, let's say, products, ad campaigns, and so on and so forth. So that's kind of what we, in a nutshell, what we've been working on. These are links to the two papers that I talked about. They're also again on this lab's website. If you're interested, and feel free to email or reach out if you want to learn more, if you have questions. Happy to chat. So yeah, I think I'm gonna pause here. See, I don't know if there's any other questions at this point, but yeah.
Yeah, so far I have a couple of questions. Well, thank you so much, Oliver, for the great
Sure.
presentation and the paper. I love the part about the distortions that you
Hmm.
find there. And my question is, besides the distortions, like what are the behaviors that are hardest for digital twins to predict, and
Yes.
why do you think is
Yes.
happening that?
Very good. So we have actually, because we have such a wide range of measures, we actually did what we call the meta-analysis, where we could see whether, okay, if it's in the political domain or the personality domain, like does it work better or less? And we do find that in the political domain, that's where the twins tend to perform the worst. So we see like these ideological biases or this inability to capture extreme opinions that really hurts the twins in that space. We also find that whenever there's questions in which there might be social desirability, so maybe there's a politically correct answer that could be given, the twins also don't do as well because they would probably tend to give that answer. So we do find some domains like this in which twins don't do as well. And then, there's other research suggesting that they also just don't do as well when you ask a question that is further away from the training data. So if you train the twins based on a bunch of observations, and then you ask, and they try to predict the behavior in a new domain, if that new domain is too far from from the data you have, it would be hard for the model to extrapolate to this new domain. So that's something that some people are finding as well.
Really interesting. And by the way, it was like one. I was just copying this. I will put it here because it's for Instagram, and that's difficult to that
Mhm,
doesn't connect. But it's
mhm.
from, what do you think digital twins are already useful today? From Lorenzo
That's interesting.
Maselucci.
That's a great question. I mean, I think there's definitely early feedback, pre-testing, if you want to get some quick feedback on on a new idea or like a new domain, or like a new study, a new question you want to ask. That could be definitely useful there. Um, there's also the more like open-ended qualitative kind of use cases. Let's say you want to do a focus group or get some customer insights. Um, Looking at the twins' responses is going to be informative, so you should take them with a grain of salt. But this might give you some interesting insights into the market. We're also seeing that people again are finding digital twins useful for self inspection. So if you're talking with your own twin, we actually find that people actually do find that this gives rise to interesting self insights, and actually it helps them go through issues. We're also seeing that digital twins again are able to reduce polarization. So if you're talking to the twin of someone who's different from you, that actually helps better understand the other person's perspective. So we're seeing some of these use cases where I guess the accuracy maybe is not as key, but it's more like the process of discovery and kind of asking the question and having conversations is helpful. So these I think are already interesting use cases. For anything that requires predicting like the market share of something or the of quantity feedback, I would be cautious. I would test before deployment, because I think again really there's a lot of areas where this could give you the wrong data points.
Yeah, totally. Mainly, and I want to follow up with the problems that you find, or I want to know a little bit more about the distortions that you
Mhm,
found.
mhm.
What was the most surprising part of those
Um,
distortions? Or
yeah, that's a good question. So I mean, to be honest, I mean these are issues that are kind of known with LLMs, and so I think the hope was that digital twins would help address those by really having agents that are really calibrated to mimic one person's behavior specifically. And so what we find is more like these aren't really enough to solve the issue. I think what was a bit surprising to me, I would say, is the some of the ideological biases. I think this notion that the twins will at the same time be very pro-human and pro-tech. So like they're very like there's a bit of a yes, bias. But then when they but implicitly they seem to actually favor tech over humans. I think that was kind of interesting. Um, Another one that was interesting to me is that I mean there has been research showing that LLMs in particular, GPT, OpenAI GPTs, which is what we use in most of the analysis, tend to have more of left-leaning political bias. We find actually that the twins don't do as good a job capturing the opinions of people who are either very liberal or very conservative. So it's really on both sides. We find that they don't do as well a job capturing anyone who has kind of more extreme viewpoints. I think that was a bit surprising. I was expecting more of a left-leaning bias. Yeah, so these are some of the. I mean, to be honest, I think we were hoping that the twins would really perform better, and that it would be a happy ending, and that everything works great. But we had to be honest and say, what, there's limitation. It doesn't really work as well as we would hope, and we're making the data publicly available for anyone to try to improve. So we would love for others to explore different ways to build digital twins to improve their performance. And so that's why we're making everything publicly available, open source, hoping to push knowledge in the space.
perfect. And I think that actually we have one more question if you have time.
Yeah.
Perfect. From
What is the biggest risk?
Pedro Liedo, what is the biggest risk for companies using digital
Digital
twins?
twin. That's a great question. Oh wow, that's a great question. So I think wow, I think to answer the question specifically, I think one of the biggest risks is looking only at the accuracy numbers, and so it's 80% accurate. That's good enough. Let's run with it. without understanding how it differs from humans in the other 20%. And I think there's a big risk because this could be enough to steer your company in directions that might be suboptimal. So again, back to this pro-tech bias. If you're testing a new technology product and then your digital twins have a bias in favor of technology, you're going to be misled by the by the data. If you're or if you're trying to find to get data that is a bit more politically sensitive, you're going to get wrong signals from the market. So I think stopping at the number and not looking at the actual content, I think is a big risk because there could basically be almost some agenda that is being pushed on you without even you knowing, you're realizing by this synthetic data that could possibly influence the company's strategic decisions. So I think that's a big risk. So I would really say try to go beyond the number, look at the content, and do some tests before deployments. Again, right now in the market, either you're skeptic and you don't do anything, or you have to trust the vendors and just assume it works, or you have to invest a lot of money and time to actually do your own pipeline. So we want to make it easier for a company saying, I'm going to spend $10, I'm going to run this study on digital twins, I'm going to run it with humans, and then I'll be able to compare for myself in my own context the data, and then I'll be able to decide. So that's what we're trying to help companies do. Instead of having to rely on gut feeling or on promises or other types of information.
Yeah, well, really, really good. And just like final question from my end, how do you see the future of digital twins with the evolution of better LLMs? Maybe they will be able to reduce those distortions.
Mhm.
So a little bit of your view
Yeah,
for the future.
yeah. So I mean, there's a bit of a debate to what extent it's actually possible to reduce the distortions. Also, one of the things we found I didn't mention is that at the end of the day, human behavior is very hard to predict. And so in our case, even, I mean, based on our analysis, we would not really expect the correlation to be more than zero point 0.3. So we never really be able to fully predict your behavior in new domains. I think with that caveat, that it's not just a matter of maybe getting better models. Actually, there are some elements of human behavior that are just very hard to predict. I think the agentic AI applications are amazing. Again, you could have digital twins doing online dating. Like, your twin is going to date 1,000 people every day, and then come back to you at the end of the day with 5 candidates that maybe you might want to check out. You could have twins go and do tasks on your behalf, capturing your preferences, being able to make reservation, do shopping, and I think also I'm very excited about the ability to create video avatars of the twins. So you might be able to actually have a Zoom call with someone's twins, and just like you and I are talking now, with a face that's moves and a voice, being able to have this in-depth conversation with AI agents. I think that's really, again, the market research is only the tip of the iceberg, but there's very vast use cases that I think will be explored. And then when we move to the physical world, if with robotics, emerging, so that there's even a whole other universe of possible applications.
Wow, yeah. Let's see how evolved like this
Yeah,
future and also human behavior, knowing
yeah,
that all the uh, digital twins is taking
hmm
some interesting part in our life.
yeah.
Perfect, Oliver. Well, great, really, really amazing with your research. I
Thank you,
love what you are doing. Your future
thank you.
papers. I want to know more about how everything is evolving. The lab. So
Thank you. So
really
we keep in
nice.
touch, yeah, and thank you for the invitation.
Perfect. Thank you. Thanks to you. Like, where they can find you, like if they have some other question or see more of your research.
Yeah, I mean, you can. I have a LinkedIn profile which I don't use very much. You can email me also directly. I can just find um,
Also,
my
here is are your papers,
yeah. So
right?
these are the papers, and you have the in the chat also the lab's website. You can also just email me directly if you want to connect, maybe more efficient.
Perfect. Well, thank you so much. Thank you all the
My
audience for
pleasure.
the questions, for being here, and thank you everybody. See you next time. Thank you, Oliver.
Bye. Bye
Bye.
bye.